Hello there. I'd like to welcome you to the Chapter 9 study guide. And this one will take a little while to draw because I'm making it really artistic. So this is Niagara Falls, or it's supposed to be, with some dolostone, shale, limestone, and shale layers underneath the falls. So Chapter 9, Running Water Study Guide. I have 20 questions for you and a bonus question at the end. So here we go. Question number 1. So we're going to talk about, in this first slide, we'll talk about the hydrologic cycle with some interesting arrows that I've drawn there. So the steps of the hydrologic cycle. Okay, what do you call step A? What's happening in A? Okay, that's evaporation. What is happening in B to cause the clouds to form? That's condensation. And what falls out of the sky? Precipitation. Now we have D, when water is going into the ground. That step is called infiltration or percolation. And step E is when it can't go into the ground. It's running off. So that's runoff. So when we consider runoff, there are two types or two forms of runoff. So there's two ways in which water can flow down a hill. And the first way, of course, is sheet flow. This is water that's just flowing all over the ground. And the other way is channel flow, when water is confined to a channel. Okay, question 1C, a continuation of step number 1, I guess. So why does water run off? What are some factors that can cause water to run off and not actually infiltrate into the ground? So this is a little multiple choice test for you. Is it because it can? Letter B says because the ground is fully saturated with water. So the ground can't hold any more water. Is that why it runs off? Or could it possibly be choice C? Water is trying to flow through an impermeable surface or barrier. Or perhaps it's choice D. That's B and C. So the correct answer, of course, is letter D. Question number 2, a nice pie chart for you. This represents all the water that's on the planet Earth. And this blue shaded area is representing a large chunk of the pie, which represents what percentage of the pie? Okay, that's 97%. And where do you find 97% of the Earth's water? Okay, that is in the Earth's oceans. And the 3% that is remaining is fresh water. Okay, question number 2B. So we're going to take this 3% fresh water, and we're going to talk about it for a second. If I shade in 2% of that, where is that 2% located of the 3% fresh water? Okay, that's trapped in glaciers, so like Antarctica and the Arctic. And now with 2C, we have the 1% remaining. And available fresh water is what it says. Does this really represent the available fresh water that's on the Earth? And if it does, is all of this fresh water easily accessible? Well, I don't know about easy because most of that is in the ground, and then you have surface sources and ponds and lakes and so forth. Okay, so I did answer yes to that one. Okay, this is a bonus trivia with the 1%. So of that remaining 1% of fresh water that we could potentially use, unfortunately scientists claim that 50% of it is polluted. So yucky water, yuck. Question number 3, this is the beginning of a river's flowing. This is where it begins flowing. And down here at the bottom is where it ends its flow. So let's talk about some names. What do you call the name of the beginning of a stream, where a stream begins flowing? Okay, that's the headwaters. And what is it called when the stream flows to the end, perhaps into a lake or even the ocean? And that is called the mouth. Okay, 3B. So your job now is to match the word, which is on the left, with its associated word or words on the right-hand side column. Okay, and I even wrote or words, so it's probably going to be more of or words. So here we go. The word on the left is headwater, or headwaters, and you're to match the appropriate word, that word, with its appropriate partner on the right. So the first choice is source. Is a relationship between headwaters and source? Is a relationship between headwaters and spring? Does delta fit into this? And the final word here is distributary. So which words better fit or closely match or have a good relationship with the word on the left? So headwaters is a source. Usually the headwaters is a spring, which is where water is coming out of the ground. And that's pretty much it. Okay, now let's talk about the mouth of the stream. So the word choices are distributary. Okay, this is source. Next we have floodplain. Okay, two more. This is a delta. And then the final word in this category is levees. So which word or words closely match mouth to the ones on the right? So you have many distributaries which are located in a feature which we'll talk about here in a minute, which is close to the mouth. Yes, there are floodplains closer to the mouth, and a delta is where you find those distributaries. And of course you find levees all along the channel toward the mouth. Question number 4, name the drainage basin types, which I'm going to show you pictures for. Name the drainage basin types. So here's the first one. This is called what? Okay, that's radial because it's radiating from a central point. Okay, next is this picture, and that is called what? Okay, that is dendritic. 98% of all streams in the world are dendritic. Third one, I've out of 4 to choose from. This is the picture, and that is trellis. And the reason why this one is trellis is because it closely resembles something like that I've drawn over on the left. And the fourth and final picture to consider of drainage basin types is this one, and it's called rectangular. This one is different from trellis because it has a pattern such as what I've drawn there. Okay, question number 5. I'm going to draw some stuff here on the left and on the right. And here come your questions. What type of drainage basin is shown on the left? Okay, and what type is shown here on the right? So on the left we have a dendritic drainage basin, and on the right we have trellis. So what do you call these things that are flowing into bigger streams? That's a tributary. And what divides the different drainage basins? So that, of course, is a drainage divide. So now we're going to consider a stream profile. And we have a letter A listed here at the top and a letter B kind of closer down to the bottom. So you're going to see this little picture many times in many subsequent slides. So your first question, between A and B, where will you find turbulent flow? Between A and B, where are you likely to find turbulent water or turbulent flow? And the answer is A, because this is a high mountain stream. It's got a lot of rocks in the channel, so you're going to have a lot of rapids. So here's the same picture, but a different question. Where are you likely to find laminar flow, smooth flowing water? So that's B. Okay, A and B again, but this time I want to find a V-shaped channel. Which one is V-shaped? Okay, that's A because the water is flowing very fast. Okay, A and B again. Where are you going to find a wide U shape? Okay, that is B. Okay, between A and B, which choice is going to represent high velocity water, water that's flowing very fast? So that's A. And where are you going to find low velocity water? Well, yeah, that's all the choices you got is B. Okay, this may be the final one here. And thus down cutting. Which one is going to have water that's down cutting into the rock? So that is at letter A. Okay, question number 7. I've drawn a stream cross section here. And I'm going to put some funny colored squares in different parts of the channel. So your job is to determine which colored square represents or depicts fast flowing water. Where is the water going to be flowing the fastest? And the answer is at the red square at the top center. Okay, that little thing was just a little divider I drew up there. Okay, question number 8. Here we are in America, and I've drawn a thing here on the map. And what I want to know about this thing is, what is the name of this watershed? What is the official name of this watershed? Well, this is the mighty Mississippi River Drainage Basin, which a drainage basin is also called a watershed. And I have an A and a B marked here on the map. Between A and B, where am I going to find the Mississippi River Delta? Okay, that is at the mouth of the stream, and that is at B. Same deal, different question. What is a pattern that is made with this drainage basin? And that is dendritic. Dendritic. Now right here, is this a tributary? Is this water that's flowing into the main stream? And the answer is yes, it is. Okay, question number 9. I have a picture that should sound familiar to you because we just talked about this picture a little bit ago. Okay, are you likely to find this cross-section, river cross-section near the headwaters or closer to the mouth? And that's going to be close to the headwaters. And I've drawn an arrow here in the picture. What does this arrow indicate? And the answer is that the arrow is pointing in the direction that the water is down cutting. Because the water is flowing very fast, it's under gravity, of course. So, and the gradient is high, so it's cutting down and thus making a V-shaped channel. Okay, question number 10 out of 20. So here we have another picture. Is this cross-section found toward the headwaters or toward the mouth? So that is toward the mouth of the stream. And here we have some yellow stuff, which of course is labeled as a floodplain. But what is a generic term for all river deposits? And this is a word that starts with the letter A. Well, that's alluvium. So all streams deposit is known as river alluvium. Question number 11. I have some weird looking tubes here with water coming out at the one end of each of the tube. I've got a small tube and a big tube. Between the two tube sizes, which one indicates a higher velocity? Where is the water shooting out under greater pressure? And that is the top tube because you have more water coming out in a given period of time. Okay, so that kind of leads to a question of what is a stream discharge? What does it mean, discharge? And I didn't write the answer, but the answer is that's how much water is flowing past a given point in a certain amount of time. So are you going to have more discharge during or after a flood, or either both? And the answer is, if you have a lot of water flowing past a certain point, if it's raining a lot, the water is going to go into that channel and is therefore going to flood, and it's going to increase the amount of discharge. So now we're going to do a little math. A squared plus B squared equals C squared. That is called the what? Okay, I'm just kidding. Okay, that's the Pythagorean theorem if you're a math savvy. But this has geological implications as well, because this right here, the C, represents the slope of this triangle, or also known as its gradient. So when we apply the word gradient to this profile, where are you going to find a higher gradient? At A or at B? And that is at A. Okay, question number 14. I have a wide thing and I have a more narrow thing labeled A and B. So between A and B, which one is going to represent a creek? Which one is a creek? And that is letter A. That's where my father and I used to go fishing, in the creek. Okay, between A and B of the previous slide are each of those previous concepts, between the creek and the river, because those are the two concepts, are those each types of channel flow? Do they represent channel flow? And the answer is, of course they do, because they're both confined to a channel. Okay, moving right along with question number 15, we have two types of streams. I want to know what type is shown on the left. This is braided, and the right one is showing a meandering stream. Okay, here we have a picture of a stream, and again, I want to know what type of stream is shown in the picture. And that is meandering. Do you see any alluvium in this picture? The answer is yes, because it's all that white junk, probably sand. Okay, now we have a cross-section of the stream's interior, and I have labeled some parts of there. Okay, which one represents the bed load? Is that A, B, or C? Okay, that's C. Which one is suspended load? B. And dissolved load is really anywhere in the water column, but for our purposes it's A. Is there evidence of saltation shown in the picture? The answer is yes. If you look in the bed load, you can see little things that are frolicking and jumping and are very happy. So that is saltation. So now I have two pictures here in question number 18. Which picture, the top one or the bottom one, shows you any evidence of levees? And the bottom one shows levees right next to the stream channel. Which one has floodplains in it? And both of them actually have floodplains. Okay, question number 19, two more questions. So here we have a stream's curve, and we have some stuff that's deposited on the interior of that curve. So the first thing I want to know is, why is it deposited on the inside of the curve? And another thing is, what is that likely to be? What sediment type? Is it gravel, sand, or mud? Another thing is, does it have a specific name if it's deposited on the inside of the curve? So to answer all that stuff, stream velocity is lower on the inside of the curve and is likely to deposit whatever. It could be gravel, it could be sand, but if it's gravel, it'll be called a gravel bar or a sand bar. But because it's on the inside of the stream's curve, it's called a point bar. Final question number 20, we have some similar looking structures, but they're found in different places. The one on the left is deposited in the ocean, and the one on the right is deposited on land. So between the two, the left one or the right one, which one indicates an alluvial fan? That's the one on the right. And where are you going to find a delta? That's the one on the left. So the final question is a bonus question. So here we have a stream, looks like a meandering one, and I have a horseshoe-shaped thing that's found on the floodplain. What is that horseshoe-shaped thing called? And that is an oxbow lake. An oxbow lake is a cut-off river meander. So that, my friends, concludes the Chapter 9 study guide.